Bismillahirrahmanirrahim. Assalamu alaikum. In this video, I will explain you the simulation of a line follower, which is our midterm and final task. Okay, so here is my schematic diagram in which I've used different sensors and motors, motor driver, and IR sensor, which is basically for line detection. Similarly, an ultrasonic sensor for obstacle detection. I've also used another Arduino, which is for serial communication, and we have also used the PWM mode, which we will cover in this video. Okay, so first of all, I will run the simulation and I will explain how it basically work. So simply displaying my roll number and line follower, and similarly the status of the robot. Either it is moving forward or moving left, right, all will display on this LCD. And similarly the distance from the obstacle, which is also displaying here, and temperature is also displaying here. Okay, so these are the three values which are we getting from the different sensors. So first of all, we will close this oscilloscope and I will firstly explain how these sensors are basically working. First of all, IR sensor, we are using three IR sensors. One is mid sensor, left sensor, and right sensor. So as there are three IR sensor, so this means we have used three inputs. Okay, so from three inputs you will get eight conditions, or you can say eight logics, eight combinations. So here is our truth table. This is basically, first of all, I will explain the block diagram. This is basically our Arduino Mega 2560, and this is the temperature sensor, voltage sensor, obstacle sensor, and three IR sensors. These all are sensors are giving inputs to the Arduino, and Arduino is giving output to LCD 16x2 LCD, and motor driver, which is L29 3D, which is also attached with left motor and right motor. Okay, so our truth table is, for IR sensor we have this truth table. Okay, if I will zoom this out little. So here is this truth table. You can see here these three sensors values: left sensor, middle sensor, and right sensor. Okay, first of all, there is a combination 000 in which I've used so this is basically the logics for our line follower. When our left sensor, middle sensor, right sensor all are giving 0 value, then it will go move reverse. Okay, so similarly when it is giving 001, then it will go move right. So one by one we will check this, either it is working according to this or not. Okay, so for reverse we have to give 00 values to all the inputs. Okay, so when we run this, first of all in this it is both are moving forward. clockwise means both are moving forward. So on the 0 0 logic, both will move reverse. When the LEDs are off, they are also showing that they are moving anti-clockwise. Okay, so when both are moving anti-clockwise, then our robot will move back. Okay, so first of all, this is working. So next logic is 0 0 1. In this, our robot will move to right, because our left motor is moving clockwise and right motor is moving anti-clockwise. So in this logic, it will move backward, right. So the next logic is 0 1 0. In this, it should move forward. We have also checked this in previous as well. So both are moving clockwise, so our board is moving forward. So our next logic is 0 1 1. On 0 1 1, it will move to right. Okay, so this is also true. You can see 0 1 1 is to right, and similarly 1 0 0 is for left, 1 0 0 is for left. So let's see. This is moving clockwise and this is anti-clockwise, so our board will move left. So in this way, all the conditions are working according to this truth table. So now we will check our ultrasonic sensor, either it is working properly or not. So you can see, firstly, there is a distance 21.87. When this distance is below than 20, then it will detect an obstacle. Okay, so because the obstacle and the distance between the ultrasonic is 20 centimeter, so our robot should stop at that point. So you can see here the motors are stopped. So ultrasonic sensors detect an object, our robot will stop. Similarly, when the distance will increase, our robot will start motion. Similarly, we have used an voltage divider circuit as a voltage sensor, which is detecting where the voltage is giving to the motor driver. So our next sensor is temperature sensor, which is using with the ADC. So it is connected with AD0 and detecting the temperature of the atmosphere. So it is also displaying here 31 degrees Celsius. Similarly, when we change this, it will represent 30 degrees Celsius. Okay, so in this way our system is working. So the next stage is this we have also used another Arduino 328P. So in this circuit, I have used PWM pin from 328P mega 328P, which is basically working for the PWM mode. So when our obstacle is removed, then I have to start the motors gradually, not instantly. Okay, so for this I have used PWM mode, and you can see how it works. When the distance is greater than 20, then it will the interrupt will enable, and you will see how it will work. So in this you will see how this will work. When the interrupt is pressed, our duty cycle will go to so in this, when our interrupt is pressed, our duty cycle will be 50, then it will go to 60 after some delay, then it will go to 70, and by the increase of 10 it will go to 80, then 90, then 100. So our motors will start motion gradually, not instantly. So here is some working of this, which is actually not showing here properly, but it is showing in our oscilloscope. So at 100 we will see how the motor will work. Yeah, the motors are moving now. Okay, so in this way we will vary the speeds of the motors. So now you can see when the interrupt is pressed, the duty cycle is 50%, and you can see the motors are moving but slowly. So it will increase with the increment of 10%. So 50, then 60, then 70, then 80, then 90, then it will go to 100. So when the obstacle is removed, our motors will move, will increase its speed gradually, not instantly. So here it is showing. Okay, so when it is 100%, then it will move. Okay, so this is basically the simulation, and I will also explain the code. So in the code we have firstly used this input output library and then delay header file, and we have also used the LCD header file, which is at this path, so it will include from here. Similarly, we have used string header file, std library header file. Okay, so first of all we have set the duty cycle to 50. This is just duty cycle is just a variable, you can say of data type double. Okay, so next we have defined also a variable, you can see a pin. See, take PA0 is triggered pin. Okay, triggered pin is basically for ultrasonic sensor. So int timer overflow equals to 0. This is also a variable of integer type. Then we have an ISR function for timer overflow plus plus, which will basically increment the overflow timer count. So next we have the main function. Okay, so in this what we are doing is basically DDRD is 1 2. Similarly DDRH is, this is basically for our PWM mode. Okay, you can see here TCCR2A COM0A1, and 1 is given to the WGM00, and similarly 1 is given to the WMGM01. So this is basically when we give 1 to WGM01 and WGM00, and similarly COM0A1, then our fast PWM mode will set. Okay, so in next we have used interrupt 2, which is basically calling set the interrupt, which calls its ISR timer overflow function. Okay, which is also given in at the end. Similarly we have used OCR4A duty cycle 100 255. SEI is basically the global interrupt function. So next we have used DCCR2A. So in the main function we have used DDRD1, which means DDRD pin 2 is an input, and similarly DDRDH pin 3 of H port is output. Okay, so next TCCR2A is basically the timer register. Okay, so you have to enable it to PWM mode. So for this COM0A1 should be 1, which basically reset the timer. Okay, and these two conditions are for setting it to PWM mode, fast PWM mode. So next we have used timer Temp SK2 equals to, in this we have used timer 2, set the interrupt which calls its ISR as timer overflow. Okay, so the next we have used OCR4A, okay, which is equals to duty cycle divided by 100 static 255. So when we give it duty cycle 100, then it will give the maximum value, which is 255. Similarly, when we will give 0 value here, it will give 0, which is the bottommost value. Similarly, TCCR2A1 CS00, which means no pre-scaling. So next we have simply initializing the LCD init, which is initializing function of LCD, which is there in our header file. I will also attach the header file in the description. So first of all, it's basically printing the string and then setting the cursor to the next line, and it will printing my roll number. So then LCD clear function will clear the LCD. So our next sensor is obstacle sensor, through which we are getting the distance, basically distance from the obstacle to the sensor. So first of all, we have declared some variables, double variable distance of double type variable, and similarly count variable, long data type, and string, which is an array of character type. So next we have used DDRA as an trigger pin as output. Okay, so similarly port D as an output. So next we have initialized the LCD and print ultrasonic. Similarly, SEI is basically enable global interrupt, which will enable the global interrupt, and enable timer 1 overflow interrupts. In the next we have enable timer 1 flow interrupts. Similarly, TCCR 1A equals to 0, set all bit to 0 normal operation, for normal operation. So this is basically the start, or you can say this is basically the initial function. Now our main loop is while 1. In this loop, which it will run again and again. First of all, port A is given one value, trigger 1 is given one value, delay and 10. Similarly, trigger pin is given 0 value for port A, and in the next TCNT 1 equals to 0, which basically clear the timer counter. Similarly, TCCR1B equals to 0x41, which is basically capturing on rising edge. Okay, which will capture the rising edge. Then TIFR1 is basically equals to ICF1, which basically means clear ICP flag. Similarly, clear timer overflow flag. Then we will calculate the width of echo by input capture. Okay, so this is in this while loop, while waiting for the rising edge, it will means when a wave is so in this way we can find the distance equals to double count divided by 466, because it's a value which is given by some calculation. We will consider the sound speed here also and the timer frequency. Okay, so we are using 8 megahertz timer. So in this line you will get the distance. Okay, so now we have to print the distance in type of string, because we our LCD uses only string or character type string. Okay, so we will convert this by using this distance to string distance value to the string. Okay, then we will use also centimeter with it as a unit. Then we will set cursor 0 1, then it will display the distance and the distance value, which is in centimeter. Similarly, we will use LCD clear, which will clear the LCD. Then we have used the temperature sensor. Basically, this is basically a code for PWM. When the distance is greater than 20, then it will give 0x00 and pin A0x02, which means when the distance is greater than 20, then it will enable the interrupt, which will basically enable the PWM mode. Okay, so the motor will increase its speed gradually, not instantly. So our next code is for temperature sensor. For temperature sensor, we have used DDRF equals to 0. Similarly, we have used ADC pins, ADC SRA 0x87 and AD mux. Okay, ADC SRA 1, which is given to the ADC SC. So this is in this way we will find the temperature. Okay, so value we have get, and this it will convert this into string. So we have get the value in form of string. Okay, so we will display it on the LCD. Similarly, our main code, which is here, which is for line follower. For line follower, we are using port E and port L. Okay, so port E is basically using as an output port and port L as an input port. So with port L we have used only 3 pins, which is PL0, PL1 and PL2. So these 3 pins are connected with IR sensor. So and port DDRE, port E is basically an output. Okay, so we will see how it will basically work. So if the distance is less than 20, then it will not go to this code, because it have to stop the motor. So port E will be given this value 0000, which will basically stop the motor, and we will also display it on LCD that the obstacle is detected. So if the distance is greater than 20, which means there is no obstacle, then it will go to this code. In this code, if the sensor is given 010 value, then it our robot will move forward. For forward, we have used these 4 pins with which is attached to the motor driver. When we will give 0101 value, it will move forward, because in H bridge, or you can say a motor driver, these pins are attached with this in 1 and in 2. So when we will give this a positive value and this as a negative value, then our motor will move forward. Okay, then if we alternate the value, then motor will move backward, or you can say anti-clockwise. For forward, it is clockwise. Okay, so when we will give 01 and 01 values, this 01 is for motor 1 and this 01 is for motor 2. So our motor will move forward. Similarly, for this condition, for all 3 ones, we will get the value for moving right. For moving right, we will give this value to the motor driver. So similarly, for this condition, we are moving to the left for this and moving to the right. These all are working on the basis of the truth table I've shown earlier to you. So this is our ISR timer 2 function, which is basically checking the value of pin D, which is we have chosen. Firstly, if the distance is greater than, you can say, if the distance is greater than 20, then it will give this a 1 value. So if this is value is this, then because we have attached on the above to pin PD2, so for PD2 you will get 0x04 value. So if this is true, then it will go to this. So first of all, I5, it is a for loop which will run from 5 to 10. What is happening there, when on the first cycle 5 into 10, it will duty cycle will be 50. So first of all, the duty cycle will 50, then it will 60, then it will 70, 80 and 90, and so, and then when it comes to 100, then it will come out of the loop. Okay, so in this way we are increasing the motor speed gradually. So if this value is not true, then it will go to else, and motor will run on the 100% duty cycle on the fast speed. Okay, so this is our project for line follower. I've explained most of it. Furthermore, I will attach the documents in the description. So I've also used the mode for serial communication, but because of short time I've not yet completed, but hopefully I have tried this on to different Uno Mega 328P, and it's quite working, but not working on my system. So that's it for now. I will most probably explain the serial communication in the next video. Thank you very much.